It doesn't take us very long to modify the calculation we did to calculate the center of pressure in the x direction. Basically, if you look at our derivation, there were a couple of places where y CP showed up, or reasons why y showed up in the equation instead of x. And if we can just go through and identify those and change them out for x's, it won't take us very long. So, by definition, we're looking for a x center of pressure that makes the moment about the y-axis the same as if we were to integrate that moment using the pressures. And so we just look at all the places where we would have to insert the x, and we just go through one by one, right? So the moment about the y-axis is x center of pressure times the resultant force, and as a result, the integration would have been over x. So we just sort of follow our way down and replace all the y's with x's as appropriate. And in the end, what you end up finding out is that that final integral that existed, instead of being the moment of inertia with respect to the y-axis, you find out that it's like a combined moment of inertia that has both the x and the y in the integral. And so, that's another quantity that you can look up for any given geometry. And so the formula for finding the x center of pressure is almost identical to the one for finding the center of pressure for the y, except for instead of the xx moment of inertia, it's the xy moment of inertia. The thing that I would note is that since x is defined relative to the center of gravity, if you have a symmetric object, there's an equal amount of the object on the negative x side of the axis as there is on the positive x side of the axis. And similarly, if you have something that is symmetric with respect to the y direction, so like if it's symmetric, if there's always a chunk of dA that has positive y value at positive y and always exists at negative y as well, so if it's symmetric about that axis, then in either case, the integral will always turn out to be zero because stuff on one side cancels with the stuff on the other side. So like a pretty good chunk of the time when you're solving these problems, the center of pressure with respect to the x-axis cancels. Not always, but as long as there's some symmetry in the problem, it usually cancels.